going to see about face recognition and in installing a library and face recognition practical session, and finally of course we are going to have the discussion and then tech news. So first of all, here the requirement is the only camera and then persons. Okay, so here we are going to capture a two kind of person. So from that we are going to do the recognizing the face. Okay, so while doing the face recognition, the first part is kind of like face detection. Okay, so this having a set of process. So first of all we need to do face detection. Okay, so this is the complete frame. So from this complete frame we need to detect the only face part, right? So face detection part, and then converting that into a grayscale or any kind of image format based on the algorithm which we are going to use. Here we are going to use the hard cascade frontal facial algorithm. Its prerequisite or its requirement is to be like image should be in the grayscale image. So we are going to crop that image and we are going to convert into a grayscale image and we are going to save it. Okay, so with the help of that hard cascade we are going to detect the face and we'll crop out and we'll save it in a grayscale to pass it into any kind of Fisher phase or any kind of algorithm, because that Fisher phase and those kind of algorithm which may require the image should be in the grayscale. Okay, so here there is a two parts. One is face detection and then face recognition. For the face detection we are going to use the hard cascade frontal facial algorithm, and for face recognition we are going to use the Fisher phase direction. Okay, so for AI masterclass, like who participated in artificial intelligence masterclass, so may know about those things clearly, because we have seen that algorithm how it works also, right? So here first of all we need to install OpenCV and then OpenCV-contrib. So first of all OpenCV-Python, so it will install OpenCV, that is computer vision library, in your Raspberry Pi. But other than that, that is not a complete OpenCV, because it is not installed from the scratch like source. So if you are installing OpenCV-contrib, so contrib files, so then you will see additional functionalities like shift algorithm or something like that. Okay, additional functionality will be there. So you just copy paste the two commands to install OpenCV as well as its contrib file. Okay, so once installation is completed, then we'll go for the demo session. So on the demo session, first of all we need to create a data set, because if that is a multiple person, so you just want to create a two persons by having two different names. First of all you just create one folder called datasets. So inside that there is nothing inside here. So first of all you just go for the program called create data.py. So first of all you just see the output, then you will understand what it means. Okay, first of all we'll see like I will create the database for name Sanjay for myself. Okay, so run and then run module. So it will capture up to 30 images. Okay, 30 images is captured now. So now if you are going inside the dataset folder, so Sanjay, it contains 30 images which is completely a grayscale images, and only it is a cropped face part, not a complete frame. It is just cropped only the face and it is converted into a grayscale also. Okay, so Sanjay is captured, and not only one person is not enough to do the training. So for that we are going to create another like another database for another person who is Tesla. Okay, so I just have Tesla's picture in my mobile phone. So I'm going to create the database for Nikola Tesla. So run and then run module. Okay, so it is captured now. Okay, so here in the dataset folder now we have two folder. One is Sanjay and another one is Tesla. Okay, so every picture is captured. So here we have two persons. So in the create data.py it is very simple. So first of all we have initialized this library called OpenCV, that is CV2, and then OS it is not required. OS is for binding the directories, and hard file, so which is required for detecting the face, hard cascade frontal facial default.xml file which is used to detect the face, and dataset is equal to dataset. We just initialize the folder, and subdata we have just initialized the who in which name we need to create the folder. And from these three lines we have checked that folder whether that folder is available or not. If it is not available, it will create a folder called Tesla, or if it will create a folder called Sanjay based on the subdata. So after creating, we just initialize the two variables called width and then height, which is like 130, 100, and we just want to we already have that hard cascade frontal facial algorithm which is already present in my directory. So in this directory, this hard cascade frontal facial algorithm is just already here. Okay, so we are going to load that hard cascade frontal facial algorithm inside that OpenCV library. So for that we have initialized another variable called phase cascade is equal to CV2, this is computer vision library, CV2 dot cascade classifier of hard file. So this will load this hard cascade frontal facial default dot XML file inside that CV2 dot cascade classifier. Okay, so in the phase cascade variable, so it will hold the algorithm of that classifier, okay, face detection. And then we have initialized the web camera is equal to CV2 dot video capture of 0. So here 0 resembles that camera 1. If you are using a multiple camera, you can put 1, that is for secondary camera, and then third camera. So likewise you can change that 0, 1, 2 like 1 or 2 or 3 based on the camera which you are using. So here I have connected only one camera, that's why I just initialized it into 0. And we have initialized another variable called the count is equal to 1 and while of count less than 30, which means it's going to iterate for 30 times. So for 30 images it's going to capture. Okay, so it will print the count, and we are going to read the camera frame like a webcam.read. So I hope we have seen in the previous session like how to interface the camera. So webcam.read, it's going to return the two return values. One is empty, one is kind of like it is kind of flag which will give you whether camera frame is available or not. But in the second return value, it's going to hold the image data like frame data. So for example, if it is capturing an image, it will hold the this image data in the variable called IM. This is the second variable, and after that we are going to convert into an array because the Fisher-Price classifier and those classifiers are going to use a binary image as an grayscale image as an input. So that's why we're just going to convert that BGR image into gray with the help of CV2.color BGR to gray. Okay, so these computer vision basic syntax and each and everything which is detailedly taught in AI masterclass. If you want, you can learn that also. Okay, so that's it up to here. And after that, now it's time to detect the phase with the help of that phase cascade. So phase is equal to phase cascade. So in the phase cascade variable, it is already holding that algorithm. So in that algorithm, detect multi-scale of gray. So it's going to detect the where the phase is located and what is the threshold and those things. So with the help of that, it's going to get the coordinates of the phase in the unit of like x, y, and then w and then h. So width and then height, and x and y going to be the point. So from that, we are going to start drawing the rectangle around the face. Okay, so whenever the face is detected, it's going to draw one square box or rectangle around the face in the coordinate. So for that, CV2.rectangle of IM, which means the variable which is already holding the frame, and x comma y, this is the start coordinate, and this is the end coordinate, and this is the color, and this 2 is the thickness of that border. Okay, so and after that we are going to do the cropping because the data set can't be saved as like complete frame. Instead of that, we are going to crop only the face part, and we are going to save that image in the directory. Okay, so for that we are going to do the cropping for gray of y plus h and x plus w. So which means source to destination and source to destination for x and then y. So it will crop, and it will be it's going to be resized for the dimension called 130,100. So after done the resize with the help of CV2.resize command, we are going to save that image by naming like 1 to 1.png, 2.png, 3.png like that. So we are going to save that image like with the help of the CV2.imWrite function. Okay, so for every iteration we are going to do the increment. Okay, so if the face is not detected, it won't do the increment. Only if the face is detected, then only it will do the increment. And CV2.imShow of OpenCV, IM, which means it's going to display the image output in the frame. And key is equal to CV2.waitKey of 10. So which means it will monitor your key press, either space or escape or control C and those things. Okay, if key is equal to 27, it will be break key. Okay, either you are pressing Q or escape and those things. Okay, so if you are terminating the code, it is highly necessary to release the camera, or else you will face the error while running the program again. So camera is already in use, so that kind of warnings or that kind of error you will face. So for to overcome that kind of errors, you will use a webcam.release function to release the camera, and CV2.destroy all windows to destroy the camera frame, which is done there. Okay, so so whenever you are running the program, so it will open the frame, and that frame it will draw the rectangle. First of all, it will detect the face. For that face, it will draw the rectangle. So for that rectangle part will be cropped out, and it will be saved in the dataset folder. Okay, so these are all about create data to create the dataset. After creating the dataset, it's time to recognize the face. So for that, we'll open the face recognizing area. So its code is also very simple. But other than that, it is going to be similar to create data code which we have seen before, because there also we have to do face detection part. So for face recognition at a real time also, we need to do the basic application, that is face detection first, and then only we can able to move for face recognition. Okay, so you just skip this part up to now. Okay, so this part is responsible for getting the coordinates of the directory which we already have. From it, it will filter out the labels. So labels in the sense, so here we have the folder called datasets. So inside that, Sanjay is one label and Tesla is another label. Okay, so likewise we need to extract that labels first. Okay, so that's why we are just using the functions called subdirectories and subpath and os.path.join. So with the help of this, we are going to extract that name or the folder name. So from that folder name, it will be identified how many names are there, or how many folders are there, or how many data sets are there, and what are all the names of each and every data set, and it will be saved in the certain ID. Okay, so and after that, so it will be saved in the images and then labels, because we are going to load that images. So from with the help of these lines of codes, so it will read each and every images which is present in a certain folder, and it will be assigned in a certain variable called images with its label. So for example, so here we have dataset folder. So inside that Sanjay, it has a 30 images. So it will record this 16.png as a Sanjay, same as like 30.png as a Sanjay. So for like 30 images as a Sanjay, and the other remaining 30 images for the Tesla. So now this program or this variable knows where the image is located and whose image is that image. Okay, either that is a Sanjay or either that is a Tesla. Okay, so likewise it will have the record and it will be saved in the array. Okay, so here these are the two variable, array variable. It is holding the images with its labels. So labels in the sense it is a name. Okay, and then it's time to initialize the classifier. What classifier which we are going to do? Okay, so here you can use any classifier. Either you can use Fisher face recognizer create or LBPH face recognizer create. Okay, you can uncomment or you can comment like this. Okay, so these things like how this Fisher face recognizer will work and those things which is detailedly explained in the artificial intelligence masterclass series. Okay, if you want to learn, you can learn. Okay, and then it's time to train it. So model.train of images comma labels. So here we are going to train labels with its images. So here model is this classifier. Okay, and after that, same as like the same procedure which we have did before, the process is to detect the face first, and then only we can able to process that images into the face recognition. So face cascade is equal to cv2.cascade classifier of har file, which means you're going to load the har cascade file which is already present in the directory, and the webcam is equal to cv2.video capture of 0, which means initializing the camera, and while true is equal to, so while true, that is infinite loop. So inside that infinite loop, it's time to read the frame from the camera, and we are going to convert that colored image, that is BGR image, into grayscale image, and then it's time to detect the face with the help of loading the har cascade algorithm. And with the help of that coordinates, it's time to draw the rectangle around the face. So this is around drawing a rectangle, and it's time to crop out that rectangle part within the grayscale format. After cropping out, it's time to resize it, because whenever you are creating a data set and then training as well as testing, that size should be very similar, then only your accuracy will be better. Okay, so that's about the face resize. And after that, it's time to do the prediction. So with the help of this prediction function, model.predict of face resized image, you will get the labels, either that is a Sanjay or either that is a Tesla. Okay, after doing that, so we'll draw the rectangle here. So on that, we are going to start printing the names. So if the prediction is less than, prediction of 1 is less than 800, which means if the prediction is there, so then it will print out the name. So name in the sense, so for that cv2.putText of IM means the image which is read from the camera directly, and the names of prediction, what is the name, either that is a Sanjay or either that is a Tesla. And then second argument is going to be the prediction accuracy level, either what is the percentage level, like either that is a 28% Sanjay or 80% Sanjay. So that kind of percentage will be printed there, and this is the coordinate where it should be printed, because it should be printed above the rectangle, and cv2.font actually plain. So this is the font, and then this is the thickness and then color. Okay, so that names will be printed in the image or frame itself. If the person is not matched with that kind of accuracy threshold, then it will print like message called unknown, or else there is another option to create another dataset folder by naming it to as an unknown. So inside that unknown, you just put up like load up like 4 to 5% unknown persons, which should not be present in the first and then second folder. Okay, so that's up to here. So cv2.imshow of OpenCV, I, which means it's going to read the or it's going to display the camera frame. So until the termination of the program. Okay, so I'm going to run the program now. You'll see the how it's working and how it's frame processing. Okay, so the first process is doing a face detection. Okay, and then only it will go for the face recognition. Okay, now if you are seeing here, it is printing as a Sanjay in the terminal or in the shell also, but other than that, in this frame which is already here, that green color rectangle is green color square is here. So and above that green color square, there it is printed as Sanjay, that is 50, 68 or 70% accuracy. Okay, so this is what which we did with the help of the put text and then cv2.rectangle, and then as well as cv2.put text functions. Okay, to write the string or to write the text with the help of this kind of computer vision function. Okay, so this is Sanjay, and I will check about the Tesla. Okay, now if you are seeing here, a Tesla is also recognized properly. That is, Tesla is 46 up to like 70-60%. It is recognized as a Tesla. Okay, so I hope you got this. This is very simple. Like to recognize the faces, it will be very helpful for a wide variety of application, especially kind of like authentication system, smart home IoT doorbell system, or face recognition like attendance system, and etc. Okay, so I hope you got this. So this functions or this source code also can be converted into for IP camera also, which the camera can be accessed with the help of your mobile phone. Your mobile phone camera, you can use it in the Python program which we have already seen before, or else you can use a Raspberry Pi camera also.